Problem number 846, hand of straights. So here we have Alice, who has some number of cards that she wants to rearrange the cards into groups so that each group is of group size. So in this case, group size is an integer, and we have the integer array hand, where each hand is the value written on it. Basically, in the hand we have cards, right? An array of integer arrays which are cards inside of our hand integer array. So we have to group them into group size. We have to return true if we can rearrange the cards into group sizes of straights, or else we return false. Okay, so here we have an example. Right, we have a bunch of cards here and a group size of 3. So our goal is to group them into 3 groups of ascending numbers, right? Strictly ascending. Okay, so my solution to this is pretty straightforward. The first thing I do is, of course, check whether or not it's even possible to divide the hand size into groups of group size, right? Because if we have, for example, we have 9 cards here, right? So if we have 8 cards, right, then of course there won't be enough cards to evenly divide them into group size of 3. So here I'm checking if the remainder is not 0, then I should just return false. So here I have a hash map that will contain the cards. So the first thing I do is, of course, initialize my hash map so that each card will represent the key and the value will represent the frequency of the card, right? So I'll do it this way. So 2, there are 2 cards. For 3, there's 1. 4, there's 1. For 1, right? 5, there's no 5. 6, there's 1. 7, there's 1. And 8, there's 1 as well. Okay, so this is our hash map. Pretty straightforward. So once that is done, I sort my hand. So let me do a bit of manual sorting. Okay, the sorting of this is, well, one that is done. So my hand is now sorted in ascending order. So here I have a for loop which iterates through all the cards on hand. Right, so here I'll have a card. We are starting at the first card, which is 1. So if the current map of this current card is empty, in this case I will just continue, right? But for this case, since it's not, I have one card that's value 1. So immediately I would reduce it to 0, right? And here I have another for loop that iterates through from the second card onwards, right? When I equals to 1. So here I have I equals to 1. So as long as it's lesser than the group size. So right now I'm looking for 2 more cards to be put inside, this current hand I have, right? So the current, obviously it will be card plus I. So the current card I have is 1. So plus I, it will be 2. So 1 plus 1, that will give us 2. So right now, basically, I'm finding for the card 2. If I can't find, that means it's impossible to group them because I have just a single one with no ascending friends, right? So here, I do found 1, so I reduce it by 1. Okay, once I reduce it by 1, I will increment to 2, and now current will become the current card plus 2, which is 3. So right now, I'm finding for card 3, which in this case, I do have, right? So I do have, okay, this 2, I changed it because I just noticed there are 2 3s. But since I do have a 3 in my current map, so I reduce it by 1. Okay, so once that is done, this for loop will end, and now I'm going to my next card, which is 2. Okay, now that is done, the current card in my hash map is not empty, it's not 0, so I reduce it, and then I have an inner for loop that checks the ascendings. So my current is the card plus I, which is 1, so that will give us 3. So I'll be finding 3, and I do find 3 over here, so I reduce it by 1, and then I will increment 2, so same thing here, 2 plus 2, this will give us 4, finding 4, which I do find, so I reduce it by 1, and this follow will end, right? As long as the group size, so basically that would mean, that will mark our second group, right? This 2, 3, 4. The first group was 1, 2, 3. Second group was 2, 3, 4. Since we don't need to return the actual group groupings, so we can just do this by just calculating the cards we need to reduce. Okay, once that is done, I go to my next card, which is 2 again, right? We're now over here, but since 2 is 0, so we just continue, right? Just skip past this. The same can be done for the 2 3s, right? Since they're both 0, and this one singular 4, right? Since 4 is also 0, meaning that we have already arranged its own group. Now we reach 6, right? So card is now 6. So again, I reduce it by 1. In my for loop, looking for its group, I increment, not increment, but I calculate my card. So it will be 6 plus 1, right? I is 1 here. I is 1, current is now 6 plus 1, meaning I'm looking for card 7 in my hash map. Since I do find it, I reduce it by 1, and then once that is done, I will increment again. So I is now 2, current is now 6 plus 2, which is 8, and we do find 8, reduce it by 0, and that will mark our last group. So once that is done, this for loop will not end yet. It has to look through all of the cards for 7, and since 7 and 8 have both 0 values, so this for loop will immediately end due to the continuous, and once that is done, we return true, meaning that we did not find any grouping problems during the for loop. Okay, so let's try one with a grouping problem. So let's say 1, 2, and 1, 3, 5, 6, for example, or 4. 1, 2, 4, 6, right? And the group size we have is 2, right? Just now the group size was 3. Let's explode it from over here. Okay, group size is now 2. So if we look at our hash map, we will get 1, 2, and let's make this another 2 and 4, for example. Okay, so again, initialize done, sorted already, it's already in sorted order. So again, my for loop, I look at each card in my hand. So starting with card 1, reduce it by 1, and then the for loop would check, right? Since group size is 2, so I'm looking for one extra card, which in this case current would be card plus I is 1, right? I is 1, card plus I is 2, so I'm looking for card 2. So I do find card 2 over here. So I do find card 2, yep. So I'll reduce it by 1, and this follow will end, and I'm good to move on. So the next card I have is 2, and now I reduce it by 0, but now I'm looking for card plus I, which is 2 plus 1, right? And this will give us 3. But since I can't find the card 3 in my hash map, meaning that I don't have the card 3 in my hand, which also means that I can't group this hand into groups size 2 of strings. So when that happens, since I can't find it, I will just return false. Okay, so my solution to this problem is pretty straightforward. That's all I have to show. Thanks.